Good evening, ladies and gentlemen. The title of my new lecture, as you can see, is Building a Tree Diagram. What do we exactly mean by a tree diagram? By a tree diagram, another term which is used for tree diagram is phrase marker. The function of a tree diagram is to do three things, okay? With a tree diagram, we want to identify the constituents of the sentence. Remember, ladies and gentlemen, that constituency is decided upon on the basis of those diagnostics such as substitution, question formation, etc. We have already discussed this. I will not go back to it. Okay. So by a phrase marker or with a phrase marker or tree diagram, we want to encode to identify the constituents of the sentence. We want to determine which constituents are adjuncts, which are specifiers, and which are complements. I have already talked about adjuncts, specifiers, and complements. Okay, so and in a tree diagram, we want also to encode or to identify the relationships between these constituents, the constituents of the sentence. Okay, so the three functions of a tree diagram are to identify the constituents, to encode them in the tree diagram, to determine the function of each one of the constituents as an adjunct, to complement, or a specifier, and to describe the relationships between these constituents. Okay, so now, a tree diagram built in this way, a phrase marker built in this way, in a systematic way, is what we call X-bar theory. Later on, I will explain to you what an X-bar theory is. The format itself is called X-bar format. Okay, I will come back to this, and once I talk about all the details of it, I will come back to the theme of X-bar theory. Okay. Suppose now, if you like, the X-bar theory describes the skeleton of the sentence. Okay, one of the things that we want to understand when we study language is how sentences are built up, how the phrases are built up. This is what I mean by the skeleton of the sentence or the skeleton of the phrase, and this is exactly what we want to do by this X-bar theory. Okay, suppose, for example, that I have a sentence like this one: the customers will order the drinks immediately. So what are the constituents in here? Which constituents are adjuncts, are specifiers, are complements? And what is the relationship between these three types of constituents? That's exactly what we want to do when we build an X-bar theory. This may be a little bit abstract, a little bit confusing at the beginning, but as we go into details, things will become clearer for you. Why do we need an X-bar theory? Suppose, for example, that we would like to construct a robot, let's say a program, computer program, okay? And we want this robot to do a number of tasks. For example, we want this robot to translate from one language to another. For the program to translate from one language to another, then this robot should be equipped with an understanding of the structure of the language from which we translate, the source language, and the structure of the language to which we translate the target language. Okay, so if this robot is not equipped with these structures, it will not be possible for it to translate from one language to another. Okay, but imagine, for example, that we have one universal format, one universal structure. Okay, if this is the case, then all that this program has to do is to use the structure that it already has to differentiate between the first language and the second language. Okay, imagine, for example, that we want this robot to communicate with us. Okay, we would like to have a talking machine, a machine that can talk to us, that can communicate with us. Again, for us to have this robot, which is always possible, is to program this computer with. One of the things that we need to program this computer with is this X-bar format, the structure of the sentence. that would account for all possible structures within the language with which we want this robot to communicate. Imagine, for example, that we want this robot to teach a language, why not? Or at least to correct mistakes, as some spell checkers do when we type in a computer, for example. Okay. Again, I mean, for a program, for a robot to do this, it should be able to tell if a certain structure is okay, is grammatical in the language, and which is not okay in that language. Again, it will need to have this algorithm. It will need to have this this X bar theory in its mind, so to speak. Okay. Imagine, for example, that we would like this robot to process a text, to read a text and understand it, and provide us with a summary of the text. Again, for the robot to do this, it should be able to tell which sentences are grammatical and which are ungrammatical, which structures are possible or are admitted in the language of that text, and which structures and which ways of building sentences are not possible in that language. Okay. Now, so what we need to do if we would like to have a robot like this one is to provide the robot with an algorithm, with a basic structure, which means that we should provide the robot with the words of the language, what we call the vocabulary or the lexicon, plus a limited number of rules. And this is the key point in here. Okay, the rules of grammar should be limited. However complex language is, the number of rules that we have should be very, very limited. Okay, and for the program to work well, we should provide it with a limited number of processes or grammatical rules. The same thing works for a child. When a child learns his or her language between the time they are born and 5 years old, for them to learn their mother tongue, the structure of their mother tongue should be as simple as possible, even if it seems to be very complicated, very complex, but deep inside there must be a blueprint, there must be a simple set of rules that the child can learn, that animals cannot learn. Okay, so this is the philosophy of what we are doing here. We would like to discover, would like to see if we can reduce all the rules of grammar of a certain language into a limited number of rules. This limited number of rules is basically what we call X bar theory. We would like to use this X bar theory in technologies by providing a robot like the one that you can see, that does different things like translation, communication, teaching, correction, text processing, etc. Would like to provide it with a limited number of rules, and would like to account for the easiness with which a child acquires his or her mother tongue. So that's the philosophy of our desire to have an X bar theory, an X bar format. Okay. Now, this X bar theory is based on 3 hypotheses. Okay, notice, ladies and gentlemen, that we will be using all the concepts that we have been studying so far. Okay, so the 3 hypotheses are the following. The first hypothesis is called the head hypothesis, or the head requirement. The head hypothesis is that every phrase, XP, VP, NP, every phrase must have one and only one head. Okay, so in all the phrases that we have studied so far, be it a noun phrase, a verb phrase, an adverb phrase, an adjective phrase, you must have noticed that every one of those phrases can have only one head. It cannot have more than one head, 2 heads, for example, or 3 heads, and it cannot be 0 head. It cannot be a headless phrase. So there are no headless phrases in natural languages, and there are no phrases with more than one head. Okay, that's what we call the head hypothesis, or the head requirement. The second requirement or hypothesis is what we call the binarity hypothesis. What it means is that branching must be binary. When we build a tree diagram, we cannot have a phrase with 3 branches or 4 branches. Yes, when we say that branching must be binary, it can be less than 2 branches. It can be 1, but it cannot have more than than 2 branches. So this is basically what we mean by the binarity hypothesis. Again, this is a hypothesis on the simplicity of language, even if language is so complex, but because the child can learn his mother tongue with ease, between the time he is or she is born and 5 years old, what we call the critical period, because they can learn it with ease. This means that there must be something so simple with language, and the most minimal the minimal assumption is to assume that branching is binary. Yeah. The third hypothesis, and this is something that I will come back to later on, is what we call the projection hypothesis. Projection hypothesis goes ahead, projects onto 2 bar levels. Do you remember when I was talking about 2 levels in the VP and 2 levels of the NP? What we call the small VP or V bar and the augmented VP, the maximal projection. Do you remember when I was talking to you about 2 levels in the NP itself, N bar or the small NP and the augmented NP, N bar and the maximal projection? This is exactly what we mean here, but I will come back to it because I would like to make it clear by looking at some examples. Okay, the projection hypothesis is the hypothesis that one phrase can be multi-layered. It can have more than one layer. It can have the small VP and then the augmented VP, V bar and VP, N bar and NP. That's what we mean by the projection hypothesis. So basically we have 3 hypotheses that we'd like to use in our account: the head hypothesis, the binarity hypothesis, and the projection hypothesis. Yeah. So let me just give an example to see what it means for a tree diagram to satisfy these 3 requirements: the head requirement, the binarity requirement, and the projection requirement. My example is John found a car in the garage. Okay, first thing you should do is to identify the words, or let's say the lexical items that you have in the sentence. You have John, which is a noun. You have found, which is a verb in the past. You have a, which is a determiner, an article in this case. Car, which is a noun, in, which is a preposition, the, which is a determiner, an article in this case, and garage, which is a noun. Okay, the determiner and the noun come together under the same phrase, and you know these things. That's the NP. It's a constituent on its own. We know it's a constituent, for example, because it can be replaced by a pronoun such as it. John found a car in it. Okay, of course it can undergo other diagnostics. This is just one example. Okay, again, this is a PP, yeah, headed by the preposition in, the complement of which is the garage. The PP on its own is a constituent. We know that because we can replace it with a proof form such as there, and I can say John found a car there. Yeah. A car is a noun phrase. Again, I can replace it by a proof form such as the pronoun it. John found it, yeah, which is an NP. And here we have a VP, and the VP is found a car in the garage, consisting of the head, the verbal head, V, found, followed by an NP and a PP. Yes, the NP being a car, the PP being in the garage. This is what we call the VP. And John is a noun. Specifically, it's more precisely, it's a noun phrase. It's the subject of the sentence, and the S that we have here is represented is on the symbol of sentence, the notation that we use for sentence. So this is our phrase marker or our tree diagram for the sentence John found a car in the garage. So we identify the lexical items and the relationship between them, and we bring them together under constituents such as the NP, the PP, the VP, and the sentence. Yeah. Now, just to introduce you to some terminologies. When we say syntactic categories, we mean parts of speech such as the noun, the verb, the determiner, the preposition, etc. We call them syntactic categories. That's the first level in a tree diagram. When we say phrasal categories, we mean the phrases such as the noun phrase, the verb phrase, the NP, the PP, and so on. That's the phrasal level. Okay. By the root, we mean the sentence itself. So the root is one because the sentence is one. Yeah. So that's it then. This is an example of what we call a tree diagram or a phrase marker, okay, in which we identify the parts of speech, the syntactic categories, and we account for how they come together in constituents, self-contained units that undergo some diagnostics. We have already discussed this, and how all of those phrases come together in this network that we call the sentence. Okay. Now, another way of representing this tree diagram is by using the rules, using arrows like these. Okay. For example, this tree diagram can be reanalyzed in terms of some rules. Okay. And here are the rules. Okay. The first rule tells you that the S, which is the sentence, rewrites as NPVP. This is S. This is the sentence. It rewrites as NPVP. This is another way of saying that in the sentence we must have an NP followed by a VP. That's a rule for the English language. The arrow that is used here is universal, theoretically relevant notation that we use in the syntactic theory. And when we state the rule, we read it in this way. State it in this way: S rewrites. That's why these rules are also called rewrite rules, because they specify how some categories are how they are substantiated. Okay, what does this category, this phrasal category, which is S, what does it consist of, and how are its constituents arranged or ordered at the linear level? What comes first and what follows what? Okay, now the second rule is NP rewrites as det, which is determiner, N. Yeah, this is another way of saying that the NP consists of a determiner followed by a noun. This is exactly what we have in the garage, what we have in a car. But why do we put det between parentheses? We do so because the det itself is optional. This is what we witness in this noun phrase, which is John. It's a noun phrase on its own, but it doesn't go with any determiner. So we put the determiner between parentheses, just to have one rule that would account for those noun phrases having no determiner and those noun phrases that are that have a determiner. Okay. The third rule is VP rewrites V and PPP. This rule accounts for this tree in here. The VP consists of a verb followed by an NP followed by a PP. Yeah. And the last rule reads PP rewrites as P and P. So look at the PP that we have here. It consists of a P followed by an NP. So the rewrite rules that we have here, the 4 rewrite rules, is just another way of saying the same thing, except that what we do when we use rules is that we break down the structure in terms of separated rules. Now, let us look at this tree diagram and see to what extent it satisfies the 3 requirements of the head requirement or the head hypothesis, the binarity requirement or the binarity hypothesis, the projection requirement or the projection hypothesis. Let's start with the head hypothesis. Look at the noun that we have here. That's the head of the NP. So the NP is headed and it has only one head, which is the noun. So it's consistent with the head hypothesis. It satisfies the head requirement, no problem. How about this one? How about the PP? It's headed by P, which means that the PP has only one head, which is the preposition. Again, this satisfies the head hypothesis. Same thing can be said about the other NP, which is a car. It has one and only one head, which is a car. Okay, A is a determiner, so it does satisfy the head requirement. Same thing can be said about the VP. Yes, it has one and only one head, which is verbal, which is the verb, followed by NP, PP. Yeah, same thing can be said about the NP. It's headed, it has only one head. But how about the sentence itself? Does it have a head? No, in this tree diagram it doesn't have a head. But actually, in the English language, the sentence itself can be headed. In fact, there are 4 possible heads for the sentence, and we call them complementizers. A complementizer is that word that heads the sentence itself. In the English language, I mean, these complementizers can head the sentence only when it is embedded. The first one is that. The first complementizer is that. When I say, for example, he told me that John was there. That John was there is a clause, and the head of this clause is that. And it gives the sentence a declarative value. So it's very important in terms of meaning, and it heads the sentence. So it's the head of the sentence. So is the sentence headed? Yes, it is headed. Does the sentence itself satisfy the head requirement? Yes, it does. We just need to show it clearly on this tree diagram. The sentence does have a head, but this head is not very clear in this tree diagram. Okay. Another possible head for the clause is whether, that we use in declarative sentences. He asked me whether I'm leaving today. He's asking me whether or not I'm leaving today. Whether is the head of a declarative clause. That is the head, whether is the head of an interrogative clause. That is the head of a declarative clause. What they have in common is, number one, both of them can introduce a clause, and both of them determine the meaning of the whole sentence. They have scope over the sentence as a whole. Another possible complementizer is if, that can head the sentence. He asks me if I'm leaving, if I am leaving. So it's declarative. We can use it in conditional sentences as well. If you don't want to leave now, I will have to change my mind about my promise. Okay? So if can be used can be used to introduce a conditional clause, conditional sentence. And it comes at the beginning of the sentence, so it is a complementizer too. It can be used as a head of a clause as well. And what it has in common with whether and that is that all of them introduce the clause, and all of them determine the meaning of the sentence as a whole. If says that the sentence is conditional or sometimes interrogative. Whether says that the sentence is interrogative. That says that the sentence is declarative. Another type of complementizer that we have in English is for. We use it in non-finite clauses, infinitive clauses. Like when I say, for example, for you to quit smoking this month is the best thing you can do. Okay, I'm just trying to imagine something, okay? So for is itself a complementizer and should not be confused with the preposition for, like when I say, this is for you, this gift is for you. For in this case is a preposition. It is followed by a noun phrase, a pronoun in my example, for you. But I mean, it can introduce a non-finite clause as well, okay? So, which means that it's a complementizer, okay? And it's there only when the verb is infinitive. So how many complementizers do we have in English? We have 4 complementizers: that, whether, if, or for, and each one of them can introduce the sentence and somehow determine the meaning of the sentence as a whole, or determine its structure, like in the case of for, that says that determines the tense of the verb, making it in the infinitive form. Okay, so this means that the clause itself is hidden, and we should make this clear. We should encode this in our tree diagram. How can we do this? One way of doing it is by adding another branch in which we point out to the complementizer, and we say that the complementizer can potentially be that. Of course, in the English language, I mean, free clauses or root clauses that are not embedded clauses are not introduced with the complementizer. I cannot say, for example, instead of saying, I'm happy today, I would say, that I'm happy today. No, we don't say that in English. But in many other languages, even free clauses or root clauses can take the complementizer. This is not the case in the English language. The complementizer goes with the clause only when the clause is embedded in the English language. But we should take it into consideration that we must have a slot, structured slot for in which we can put the complementizer if it's needed. Yeah. So now our sentence, our tree diagram satisfies the head hypothesis. But so instead of calling it the sentence beginning from now, we will be using the term CP, which stands for the complementizer phrase. So we say the VP, the verb phrase, the NP, the noun phrase, the PP, the prepositional phrase. Now we want to say the CP, which means the complementizer phrase. This is just to indicate that the sentence itself, the complementizer phrase, is itself a phrase which is headed by one and only one complementizer. Okay, it cannot be more than one complementizer. So by so doing, we can say that our tree diagram is now consistent with the head hypothesis. Now, how about the binarity hypothesis? Look at the tree diagram again. Look at the NP. The NP has only two branches, which is okay. The PP has only two branches, which means that it satisfies the binarity requirement. The NP in here satisfies the binarity requirement, only two branches. The NP has less than two branches, which means that it's okay, because the binarity hypothesis tells us that a phrase cannot have more than two branches. If it has less, it's okay, but more, no, it's not okay. But how about the VP? Look at the VP, it has three branches. So in this case, we can say that the VP does not satisfy the binarity requirement, nor does the CP in here, having three branches. Okay, which means that this tree diagram is not really up to our expectations. We want it to be binary. We want a tree diagram to have only binary branching. So to do this, I will suggest to make some changes to rectify the tree diagram, but I will talk to you about this rectification that has been suggested by syntacticians by giving you examples. Imagine, for example, that I have a phrase such as always in the garage. Which type of phrase is this? If your answer this is a PP, a prepositional phrase, then it's correct. What's the head of it? It's the noun, which is a preposition. And then the complement of it is the garage. Yes, so what we have here is a preposition plus its complement, which is the garage. So P and the NP, both of them, using the projection hypothesis, is P bar. Remember, when we studied the structure of the VP, it turned out that we have two layers. The first layer is that of V bar, what we called the small VP, and the second layer is that of VP, which is the augmented VP. Same thing should apply to the preposition. Yeah. So, and then, I mean, the whole PP is modified by an adverb phrase, which is always. Okay. So what we want to say then is that the PP itself has an adverb specifying the meaning of the preposition phrase, which is a P bar. Now let me introduce you to the terminology that we use in syntactic analysis. Okay, the NP is the complement. That's the term that we use. That a part of the sentence that specifies the meaning of the PP specifies the place. the time of it, okay, is called a specifier. We have already studied specifiers, so I will not go back to this again, okay. So we have a specifier. The PP itself is the maximal projection because it's the highest node in our analysis, our syntactic analysis of the PP, yeah. And the P is called the head. So I hope now that because we will be using these terms, okay, I hope you will be able to remember them, okay. So we have the head, which is the P, we have the complement, which is the NP, we have what specifies the meaning preceding it is called the specifier, and then we have a maximal projection. Is the branching here binary? Yes, it is. Is it does it satisfy the head requirement? Yes, it does, because it has one and only one head, which is P. And does it respect the projection hypothesis? It does, because we have two layers of projection, the P bar and the PP. The P bar and the maximal projection. That's it. That's an example with the PP. Now, it works this way. We have a head, and then this head takes a complement, and the 1 bar level is itself x that projects onto x bar. It must have a specifier. Let's call it yp. The yp can be any phrase, okay? And then this projects onto xp. See? So this is the structure of the phrase. This is the skeleton of the phrase, so to speak. Again, the zp is the complement, the yp is the specifier, the xp is the maximal projection, x is the head. And again, if you would like to use the rules, rewrite rules rather than the tree diagram, is we can say that the xp, which is the maximal projection, rewrites as yp x bar, yp x bar, and x bar itself rewrites as xzp, xzp. So that's the x bar format. This is an x bar format. It applies to the PP. Now let's consider the case of the CP, what we call the CP, the complementized phrase, which is the sentence. Again, this is an embed. Remember that the English sentence take a complementizer such as that, whether F or for, only when it's embedded. That's why I'm using the 3 dots here. That's the irrelevant part of the sentence, and it starts from here. This is an embedded clause. Okay, that he will come. That he will come. Again, the head is C, which is that, and the complement of the head of the complementizer is what we will call an IP or an info P, inflection phrase. By I or inflection, we simply mean the auxiliary. Beginning from now, and I will come back to this again, beginning from now, we will call the auxiliary inflection, and we will be representing it using either I or info. So the complement of C of the complementizer is IP, yeah? So what is the first projection level? If your answer is C bar, then it's correct. Yes, it is. Again, we would like to add a specifier, and then we will come up with a CP. Again, the rule is CP rewrites as YP C bar. This is the YP and C bar. I will come back to this YP because, I mean, you may be wondering right now, what should we put in here? What does it stand for? I will come back to it in a moment. Then we have C bar that rewrites as CIP. C, and the complement of which is the whole sentence. He will come, yeah, that we called IP. And I will explain to you why we call it IP, okay? So he will come. C is that. Now, how about this YP? What should we put in here? This is the place of WH words such as who and what and where and when, etc. Because all of these WH words move from their original positions, from their canonical positions, to this position. I mean, to the leftmost position of the English sentence. But I will not say much about this today. Okay. Now, take this one. IP, or the inflection phrase, or the auxiliary phrase, yeah, the head of which is the auxiliary, okay? That's the I, or the inflection. Okay, and the complement is the VP. Do you remember when I was showing using those diagnostics that the auxiliary is independent from the VP? Do you remember this? Here we are. You remember when we proved that the auxiliary and the VP would constitute one constituent that we called auxiliary phrase, or now we will just call it I phrase or inflection phrase. It's the same thing. Please, if you don't, if this idea is not very clear for you, you can just refer back to my previous lecture. Okay, and then we have a specifier. I will come back to the nature of this specifier. And what is the maximal projection? The maximal projection must be IP, or inflection phrase. Yeah. So again, if you would like to use the rewrite rules or the rewrite format, the IP rewrites as YP followed by I bar, yeah, which is in auxiliary phrase, auxiliary bar. I bar or auxiliary bar rewrites as I followed by the VP, and that's it. So the VP itself is hicam, the inflection is well, and what is the YP? What is the specifier of IP? Again, this is a point that I will come back to later on, but let me just hint at the final analysis. In our final analysis, we will prove that he is the specifier of VP. And then it must move from this position, from this, the specifier of the VP position, to the specifier of IP position. Unfortunately, in my course or at this level of your understanding, I will not be able to talk about this. This has been called in the syntactic literature the VP internal subject hypothesis, which is another way of saying that originally the subject is a part of the VP, but then it moves from the specifier position of the VP to the specifier position of the IP. In my in the tree diagram that I will give you as an example in my today's lecture, I will come back to this idea. Okay. Now let us look at the VP. The VP itself, the head of it is the verb. In this case, the verb has no complement because the verb is intransitive. Okay, so we have the V bar level. It must have a specifier, which is the subject. And remember, one of the reasons why we want to put the subject in the specifier position, because it has all the specifier head relationship properties. For example, it agrees with the verb, as I explained previously I think in my last lecture, in my previous lecture. Okay, so then this would project onto VP. Again, this if we would like to translate this little tree diagram into rewrite rules, we will end up having VP rewrites as NP V bar. V bar rewrites as V. It doesn't have a complement in this case. Yeah. So the verb is come, and the subject is the specifier of VP, he. Now, if you want to bring together all these analysis of these phrases in a close structure, we will end up having something like this. So look at this. This is the specifier. This is the complementizer phrase. It branches out into specifier. This is the landing site of WH phrases, as I explained before, like when, where, who, why, etc. They move from the VP phrase into here to this position. But this is not something that I will not tackle in my lecture today. So again, the CP branches out into a specifier, C bar, C. The complement of C, which is the complementizer, is the IP, which means the clause, auxiliary phrase. Again, specifier, I bar, I, which is the auxiliary. The complement of the auxiliary or the I, the inflection, is VP. VP branches out into a specifier, which is the subject position, V bar. Okay. In our case, the verb come itself is intransitive, but otherwise the V bar would branch out into V and NP, which would be the complement of the verb. Yeah. So here are some questions for you guys, just to make sure that you understand how we built this tree diagram, and you can use the relevant terminologies. What are the heads in here? Yeah, so the answer should be, we have three heads: the complementizer, the inflection, which is the auxiliary, which is well, and the verb. So we have three heads. Yeah. What are the maximal projections? And remember, by the maximal projection we mean the phrase level, the phrasal categories. So we have the CP, which is the maximal projection of C, of the complementizer. We have the IP, which is the maximal projection of I. We have the VP, which is the maximal projection of V. So each head must have a maximal projection. So which means that each head must have two projections: the one bar level, like V bar, like I bar, like C bar, and the maximal projection like the VP and the IP and the CP. This is specifically what we called the projection hypothesis. The projection hypothesis now should be reinterpreted to mean that every verb must be projected onto one bar level, X bar, and the maximal projection, XP. Now the third question is, what are the complements of C and I? Here is C. What's the complement of C? Your answer should be that it's IP. That's the correct answer. What's the complement of I? Your answer should be that it's VP. That's the correct answer. Yeah. So the maximal projections are VP, IP, CP. The heads are V, I, C. We have three specifiers because we have three phrases, three heads, three maximal projections. That's it. Now, what is the X-bar theory then? If we generalize over all those tree diagrams of the PP, of the VP, of the CP, of the IP, we will have just one abstract format, and the format is the following. Okay, XP rewrites as ZP X-bar. Okay, XP rewrites as ZP. ZP is the specifier, followed by the one bar level, which is X-bar. Okay. And here it is, it works this way: XP, okay, ZP is the specifier, X bar is the one bar level, like V bar, like N bar, like I bar, like P bar, etc. Okay, and then the second rule is X bar rewrites as XYP. X is the head, YP is the complement of the head. Remember that the complement itself is optional. For example, in intransitive verbs, we don't have any complement. We can just put it between parentheses to indicate that it's optional. Okay, so X bar rewrites as X followed by YP. Yeah, and here is the tree diagram itself. Okay, X bar rewrites as X having YP as a complement. So XP rewrites as ZP X bar, ZP being the specifier, X bar being the one bar level. X bar rewrites as X, which is the head, having a complement, which is YP. Okay. The third rule is XP rewrites as AP, XP, AP. What is this? Okay, what's this? What do we mean by that? Okay. So XP rewrites as XP, AP. What do we mean by this? By this rule, we would like to make sure that we can adjoin something to the level of XP. I have already talked about adjunction. Okay, so we would like to make sure that adjunction can be done to the XP level as well as to the X bar level. Okay, and I will not be able to justify why we can have adjunction to the XP level at this stage, but I just want to give you this rule because we may need it in our analysis. Okay, so remember that we have two types of adjunction: left adjunction and right adjunction. Okay, so what we have here is a right adjunction. We are adjoining AP to the right of XP. Look at the iteration. We are iterating XP just to make sure that AP is a segment. If you remember my garage metaphor, it's a part of it, but it's somehow independent from it. Okay, so we can also have left adjunction as we have in this new tree diagram. In the first one we have XP, YP, but we can also have AP, XP. Okay, again, I mean, it's XP which iterates, and the AP is left adjoined to it. Okay, we would like to make sure that we also have a rule for adjunction at the X bar level itself. Look, X bar rewrites as AP, X bar AP. This is another way of saying that we can bring an adjunct and adjoin it to the X bar level like this, okay? So X bar, we can iterate it, okay? Adjoin it, an adverb, a PP, any type of adjunct to it. Now it's X bar that iterates, as you can see. But we can have left adjunction as well as right adjunction. In this case, we have left adjunction. In the first one, we had right adjunction. Now left adjunction. Let's go back to our robot again. As I told you at the beginning, for us, I mean, to program a robot to use language, but you use it in communication, in translation, in any other language task. So we want to make sure that this robot has a limited number of rules in its mind, so to speak. Okay, we would like to instruct this robot to translate, to teach language by correcting some fragments of it if they are incorrect, by translating from one language to another. But for us to do this, we should make sure that it has a limited number of rules, because if the number of rules that it has is not finite, is infinite, then the robot will not be able to use it. Okay, if the number of the rules that we have is infinite, no child will be able to learn his or her mother tongue within 5 years. That would be an impossible task. Okay, so now we can say that this X bar format applies not only to the English language but to other languages as well. Okay, the claim is that this X bar format is somehow universal. It applies to all the existing languages, and because it does apply to all the existing languages, all that we need to do is to instruct our robot by putting these rules in his mind, okay, and by getting him to put words from different languages, okay, and by so doing, our robot will be communicating in different languages, in different languages, and even translating from one language to another language. So that's the idea. Okay, here is an exercise for you guys. I would like to give you, how many sentences? I would like to give you 4 sentences, and I want you to build a tree diagram for each one of them, okay? The customers will order the drinks. Look at this sentence. So the customers is the subject, the verb is order, it has one inflection, one auxiliary, which is well, and the object, which is a part of the VP, is the drinks, the head of which is drink, and the specifier of which is the determiner. Okay, so please, I would like you to build a tree diagram for each one of these, but to help you, I will do one of them for you, which is number 2. Okay, the customers will order the drinks immediately. Okay, so if you would like to draw a tree diagram for a sentence, analyzing it syntactically, what it takes is the following. Number 1, make sure to have a blank sheet. Okay, a full blank sheet. Okay, number 2, please write the sentence at the bottom of the sheet. Yeah, and then you start by the word level, or by the lexical categories. Okay, how many words do we have here? How many lexical categories we have here? We have the, which is a determiner. That's the first part of your analysis. Customers, which is a noun. Will, which is an info, an auxiliary, an inflection. Order, which is a verb. The, which is a determiner. Drinks, which is a noun. Immediately, which is an adverb. Okay, and then you should start combining the words together in constituents. For example, I mean, customers should project onto n bar in accordance with the projection hypothesis. Remember that in every noun phrase we should have 2 layers or 2 levels, the 1 bar level and the maximal projection. We want to use the X bar format. Okay, and the determiner is the specifier. I have already explained to you in my previous lecture why we want to take determiners as specifiers, and this is our NP. I'm putting this specifier here just to remind you that every XP, the NP in this case, must have a specifier. Please don't forget the specifier, even if it's empty, even if there is no, even if actually there is no specifier there. Okay, you should put it there just to remind yourself that there may be a specifier. If it's not there, there may be a specifier in another phrase. Okay. Same thing for the drinks, which is also a known phrase. I project the n onto n bar. The determinant itself is specifier, and we'll end up having an NP. Again, I'm putting the spec here just as a reminder for you. The adverb should project onto adv bar, just like n bar, v bar, and then add phrase. Add phrase is the adverb phrase. So here we have a verb that should project onto v bar in accordance with to satisfy the projection requirement. The NP itself is the complement of the verb, so that's a v bar. Okay, what we call a small VP. Now we don't say the small VP anymore. We use a more sophisticated term, which is v bar. Okay. So here we have an adverb, which is an adjunct, okay, which means that we need to iterate the v bar. So you iterate the v bar just to adjoin adverb phrase to v bar. Is this a right adjunction or left adjunction? Of course, this is a right adjunction. Yeah. This is the VP level, the maximal projection. If you once you decide that there is a v bar, you should project onto a higher level, which is that of the maximal projection VP. Again, because this is a maximal projection, it must have a specifier. What is its specifier? As I explained to you before, the specifier of the VP is the subject. But the subject must move, because it must move from this position to this position, to the leftmost position of the sentence, as I explained before. I'm using this phi symbol just to indicate that something has moved from here. This is the trace of the subject position, okay? It has moved from this position to the position of the leftmost position in the sentence. So this is in fact the VP, the customers, okay? Now here we have the VP. The VP is the complement of the info. Yeah, so and then we would project it onto info bar. So info is the head, the complement of which is the VP. Remember, the X bar format says that the X bar rewrites as X followed by its complement. And the X in this case is info. It projects onto info bar. So the info bar should dominate the info and VP, its complement, the VP. Yeah. So now we should project it onto info P, which is the maximal projection. Because it's a maximal projection, it must have a specifier. What is the specifier of the inflection? This is the point I was trying to explain, and this is what I meant by the leftmost position to which the subject moves. In fact, the subject moves from the specifier position, from the specifier of VP to the specifier of info phrase. Okay, so the specifier of info phrase is the subject, which is the customers. Now this is a detailed analysis of the sentence. The customers will order the drinks immediately. Please try to apply this to the other sentences, to the other 3 sentences that I gave you. Please, if you have any questions about this, please let me know. You can send me your analysis of the 3 sentences that I gave you, and I will come back to this to help you to build more tree diagrams for more sentences in my next lecture. Thank you very much. See you next time. Bye.